Okay, today we're going to talk about solving absolute value equations and inequalities. Day one is going to be equations. Tomorrow we're going to talk about inequalities. So let's get right into it here. First things first, let's talk about what absolute value is. It's actually the number of spaces a number is from 0. Okay, and distance can never be negative, so we know that always the absolute value of a term should be a positive value, a positive distance. Okay. So that's just a brief overview of absolute value. Hopefully we've done this before. Okay, if you haven't, we'll get more familiar with it here on this next problem. The directions say solve and graph the solution. So without doing any algebra, I want to just think about what the solutions could be. I know that in order for it to be a true statement, the left side has to equal the right side. So initially I'm going to say, all right, well, there's two numbers. This is 0, and our absolute value means the distance away from 0. There's two numbers that are 5 away from 0. 5 and -5. So using my common sense, I know the absolute value of 5 would equal 5. So x could be equal to 5. Or the absolute value of -5 is equal to 5. So I know x could also equal -5. Both of these solutions make the statement true, the equation true. So I actually have two solutions. More often than not, in an absolute value, you will have multiple solutions. Okay? So as far as solving the equality, we've done that. We use common sense this time. Okay, there's a better method, but for now we're using common sense, and we know that 5 and -5 are the solutions. I'm going to go ahead and graph those on my number line here. A solid dot on 5, solid dot on -5. Okay, so there's a very basic, very simple example, okay, just to lead us into it, what we're doing here. Let's add one little more step of difficulty. Let's say the absolute value of x minus 5 equals 7. Now, kind of like the last example, I need a value here that's equal to 7 or -7. But instead of just trying to figure it out in my head, what I could do is I could say, all right, whatever's in this absolute value must be equal to 7. So I could write an equation x minus 5 has to equal 7. Or I could say whatever is in this x minus 5 has to be equal to -7. So I could separate it into two parts, two equations. Using basic algebra, I'm going to solve each part. X could equal 12, or x could equal -2. Now, just to be safe here, because this is our first time we've ever done this, let's plug these values in and make sure they work out. If I plug 12 in to my equation, 12 minus 5, the absolute value of that should equal 7. And turns out the absolute value of 7 is 7. If I plug in -2 for x, the absolute value of -7 is also equal to 7. So alright, so our method works. We have two solutions. What I had to do is I had to separate the absolute value into two equations. Finally, I need to graph my two solutions. We said that x equals 12 makes the statement true, and x equals -2 makes the statement true. So I'm going to go ahead and plot those on my graph here. There's x equals 12, and x equals -2 right down there. I have my solution set. As you can see, let's move on to another problem. Okay, now that we kind of got the idea of what's going on, let's go ahead and make our two equations. We know that whatever's in here has to be equal to 45, or it could equal -45, because the absolute value of 45 is 45, and the absolute value of -45 is 45. So let's go through it a little quicker this time. My first equation could be 5x minus 10 equals 45. My second equation will be 5x minus 10 equals -45. So let's check it out here. Add 10 to both sides. 5x equals 55. Divide by 5. X equals 11. Over here, add 10 to both sides. 5x equals negative 35. Divide by 5. X equals negative 7. Okay, so I've got two solutions here. Let's just, for the sake of us being still new to this, we'll plug them in here. 5 times 11 minus 10. I know that's 55 minus 10. That is 45. The absolute value of 45 is 45. Very good. When I plug in negative 7, I get 5 times negative 7 minus 10. Negative 35 minus 10 is negative 45. The absolute value of that is 45. I know I've done my equations correctly. I'm going to go ahead and graph these on the number line. One closed dot on negative 7, one closed dot on 11. Okay. Moving on. An extraneous solution occurs sometimes in absolute value equations when you have a variable on the other side of the equality. Talking about this guy right here. This guy over here, there's a variable on the other side of the equality, not inside the absolute value sign. Okay, and what that means is that we're going to get a solution that when you plug it back in, it doesn't really make a true statement. Okay, so you have to be careful whenever you see that variable on the right-hand side of the equation. You need to be careful and plug in your solutions and make sure they work out. So what we're going to do, it says nothing about graphing. All we're going to do is solve and make sure our answers are both true. Okay, so here we go. We're going to say 2x plus 12 must equal 4x. In our second equation, we could say 2x plus 12 equals negative 4x. The reason being, because if this is really equal to 4x, the absolute value of 4x would equal 4x, and the absolute value of negative 4x would equal 4x. So those are my two equations I can set up. Do a little algebra here. I like all my variables on the left-hand side. Do a little algebra. X must equal 6. There's one solution. Before we go on to the next part, let's see if this is an extraneous solution. That means if I plug it in and it doesn't work out, it's no good. I can cross it out. So let's plug that in here. Let's plug it in over here on the side. Let's say, okay, 2 times 6 plus 12, the absolute value of that whole thing should equal 4 times 6. Let's find out. The absolute value of 12 plus 12 should equal 24. Well, the absolute value of 24 does equal 24. So yes, this is a good solution. Moving on to our second equation. Do a little algebra. Get all my x's together. X equals negative 2. We need to be sure that this is actually a solution, so let's go ahead and plug this guy in right up here. The absolute value of 2 times negative 2 plus 12 should equal 4 times negative 2. Let's find out. Is the absolute value of 8 equal to negative 8? It is not, because the distance 8 is from 0 is a positive 8. And can we ever get a negative number for a distance? No. This would be an example of an extraneous solution. X equals negative 2. It's not a true solution. Okay. Our only solution will be x equals 6. You're going to need to cross out x equals negative 2. So let's take another look. Look at another one here. Absolute value of 2x plus 5 equals 3x. I'm going to cut right to the chase, my two equations. One positive on the right hand side, one negative on the right hand side. Do a little algebra. Get my variables on the same side. X equals 5. That's one solution. Let's plug that in right away. See if it works. 2 times 5 plus 5. That's 10 plus 5. That should be equal to 3 times 5. Is the absolute value of 15 equal to 15? Yes, it is. Okay, so this is a good solution. Let's try the other side now. Get our x's on the same side. X equals -1. Let's make sure it works, because whenever there's a variable on the right hand of the equation, you might get an extraneous solution. Let's find out here. -2 plus 5 equals -3. The absolute value of 3 is equal to -3. Is that a true statement? No, it's not. Absolute values, anything in the absolute value, should equal a positive number, because distance from 0 will always be positive. So this would be no-go. It's no good. This is not really a solution. It's extraneous. It does not fit our original equation. So let's try one more here. This is a little more complicated. Once again, I'm just going to go ahead and make my two equations. But you need to be careful here, because not only is the -2x changing its sign, but the 9 is also changing its sign. It's basically a distributed property of the -1. So what we have for our second equation would be 4x minus 1 equals -2x minus 9. We'll solve our left equation first. Let's go ahead and get our x's together. 1, x equals 5. There's one solution. Let's see if it works now. I'm plugging it into my original equation. See the value of 4 times 5 minus 1 equals 2 times 5 plus 9. And as you can see, the absolute value 19 does equal 19. It's true. This is one of my solutions. My second solution, okay, now remember, we got this right hand side because we had to distribute this -1. The whole term on the right hand side changed to a negative term. Add 1 to both sides. Add 2x. X equals -4/3 when I reduce. We need to see if this is truly a solution. Let's find out. I'm going to have to erase a little bit of work here, I think. We said that x equals -4/3. Let's plug that in to our equation and see if it works. The absolute value of 4 times 4/3 minus 1 so the value of -16/3 minus 1 should equal -8/3 plus 9. Let's get our like terms here. The absolute value of -16/3 minus 3/3 should equal -8/3 plus 27 thirds. Let's find out here. Negative 16 minus 3 is negative 19 thirds. And that is equal to 19 thirds. Is this true? The distance from of negative 19 thirds to 0 would be a positive 19 thirds. So this, in this case, it did work out. Both are solutions. X equals negative 4 thirds and x equals 5. So that's about as hard as they get for today.